System of equations is one I don't really like, but yeah, I mean, you guys are learning it, so I guess it's good to know. So if I'm a little rusty on this, don't blame me, because I don't really do system of equations that much. So here, I was given 3 examples, and then there's also one more, but I'm gonna leave it up to you guys because you guys deserve practice. So I'm gonna show you guys right now, and hopefully it'll help. Maybe it won't, maybe it will, who knows. So our first one, we see that we are given 2 linear functions. And the best thing to do is to always put it into a form that's the same. And the best one I like to use is to use the form a and then y is equal to and then like another constant, so like bx and then plus a c. Like always putting it in that form will actually make it a little bit easier. So if you want, you can always rearrange it to that, which will probably be very beneficial, right? Alright, so let's rearrange it so we can get to that form. We see that this is in that form already, so that's actually really good. So I'm going to put that down here. But up here it's not. So how do we get it into this form right here? Well, we see that we have a 2y here, we have a 3x there. I'm going to add 2y, and I'm going to add 2y there, but as I add 2y there, I'm going to subtract 3x over there. So it'll be 2y, so if we added it, it'll be 2y. That'll be equal to 10, and then we subtracted the 3x, so it's going to become here. And now I'm going to actually just rearrange this more. I'm going to put the 3x here, and I'm going to put 10 over here. So this will just be equal to negative 3x, and then plus a 10. Alright, and now we see that we have, now it's in that format that will make it easier for us. And we see that, wait a minute, we have a negative 3x here, we have 3x here. We can actually use this, we can actually use, we can solve this by using elimination. I don't know if you guys were taught that or not, but you can use elimination to solve this, because if you were to add these 2 equations up, you'll see that this 3x and that negative 3x will cancel each other. So then you just be left with, you just adding that, which would just be a 7y. And then this is just going to be negative 28. And then to solve for y, you just divide it by 7. So y is equal to, that would just be negative 4. So that's y. And then we have, to get x, well now that we have y, we can just go back to the original equation and plug in what y is. I'm going to use the top one. So we just plug in y, so 3x is equal to 10 minus 2, our y is 4, negative 4, so it would be negative 4. And then we just solve for x. 3x is equal to 10, this would be a positive 8. Then we can combine that, which would just be a 3x is equal to 18. We divide by 3, so we see that x is equal to 6. And if you want to write it, now we have the 2 answers, but if you want to write it in like a point thing, you can write it as like 6 and then negative 4. And there you go. Check the answer, of course, but I'm not going to check the answers. You guys can check the answers. Alright. Here we have another one. So here we have x plus 3y is equal to 0, and we have x minus 2y is equal to 10. Luckily for us, it's in a format that we like. It's fine, as long as the format matches with each other. But we see we have a x here and an x there. If we were to add it by elimination, we wouldn't really cancel anything out. So wouldn't it be nice if this x up here or this x right here was a negative? That'd be pretty sweet, right? So what I'm going to do is that I'm just going to take the top here, I'm just going to multiply everybody here by a negative, or a negative 1 if you want. So this would become, you can just distribute, distribute, right? So I'm going to rewrite this as, that'll be negative x, then that'll be a negative 3y, and it'll still be equal to 0, and then you have your x minus 2y is equal to 10. And now you can use elimination, because when you add it, you see that this negative x and that x will cancel each other. So now we have here, this would be negative 5y is equal to 10. You divide by negative 5, divide by negative 5. You see that y is equal to negative 2. Okay, and now we just plug in our y into the original. I'm going to use this one, because why not? So that would be x minus 2, our y is negative 2. And this would be equal to 10. So we see that we have a negative 2 and a negative 2, that would be negative 4, so that would be x plus 4 equals to 10. Subtract 4, we see that x is equal to 6. So now we see that our final answer is 6, negative 2, and don't forget to always check the answer if that is correct. we have another one, the last one. So we have 8x plus 9y is equal to 129. Then we have 6x plus 7y is equal to 99. So this one's pretty hard because you can use elimination, but would that work? I'm pretty sure you can, but I mean, yeah, we can. We can try and cancel x, but that'll be a big number to multiply it by. You can find common. Yeah, we can just let's just use elimination. Why not? Because I feel like if we were to just like use like plug in or like do it the long way, it would be pretty freaking hard. I mean, we can. You know what? Let's just do it the long way. Yes. You can probably see why we don't do it this way, because it takes a long freaking time to do. So we're just going to deal with fractions. So I can't just waste your time. So let's not do it like this, because it takes so freaking long. I don't feel like doing that. I mean, you can do it like that if you don't really know what else to do. But let's just do it the elimination method, because it's just easier. So you kind of want to get y. If you want, you can get y or x to find a way you can cancel x or y. But the way to do it, the way I like to do it, is to find a common, or like the least common multiple of x, or whichever numbers are small. So we have an 8 and we have a 6, and we kind of want to find like the least common multiple. So we see that, like, hold on, 8 times 3 is 24, right? 8 times 3 is 24, and we also see that 8 times 4 is 24, right? So maybe we can use 24 as the least common multiple. So let's do that. So what would get this equal to 24? Well, that's going to be a 3. So I'm going to multiply everybody here by a 3. Here, I'm going to multiply everybody here. What would get this a negative 24? Because again, in order to use elimination, we have to cancel it out somehow when we add them together. Well, we need a 4 to get 24, but we need a negative. So I'm going to multiply this by a negative 4. So you'll see that when we distribute everybody, you know what to do. We distribute it, so that would be a 24x plus 27y is equal to 129 times 3 is 7. This will be a 6. This will be a 8. This will be a 3. This will be a 387. And then we distribute that. That would be negative 24x plus just getting minus 28y is equal to 99 and a 4. This would be a 6, 3, 4 times, that would be 36. And then 36 plus 3 is going to be a 39, so that would be 396 negative. My bad. Alright, and now what we do, we just add them together. So we're going to add those two. So now we see these will kind of cancel out. And then we can add these. Trains, that would be negative y is equal to 387, so that would be like 396 minus 387. It will be 9 negative. So now we just divide everybody by a negative, so that would mean y is equal to 9. Yay! And then we plug into x. So we see that we can take whichever equation we want. We're just going to do this one, why not? Because that'll be 8x plus 9, shout out Hitler, is equal to 129. So then what we can do is that we can just do 81 plus 8x equal to 129. And then this would just be minus 81, and then that'll be over 8x equal to 129 minus 81 would be 48 divided by 8 divided by 8. See that x is equal to 6. So our final answer is going to be 6, 9. Nice. But now you can just check your answer and always make sure you check those answers. There it is. That's all you have to do.